All right, folks, good morning. That was the bell. So at this point, we should be in our seats with our workbooks out. How did it go on last night's homework? Pretty good? That's great. So please take it out. Make sure you have your pencil out. Let's talk about our plan for today. So if we look at our agenda, we are continuing to practice and apply what we've learned. So through page 14 should be complete. If we're coming in without a pass, please be aware that tardies will start to add up, okay? No worries, just be aware of it. So please open up to what last night's homework was. The bell did ring, so right now we're not passing things out. We are taking our workbooks out, opening up to last night's homework. Let's make better choices. Yes. So right now I'm a little bit behind on my grading. My goal is to get your test done over the weekend along with tests from some other classes. I will be checking through the type 3 on Monday. So if you've been doing what you're supposed to be doing, you could actually leave here with no homework. If not, this weekend could be your saving opportunity to catch up on what's not done and be able to still get full credit. That also means if it's still blank on Monday, is there any time past Monday? No. So let's take a little preview of what's coming. Today, the focus is the type 3. The fact that we're on a type 3 means that really we should be able to do all of this how? With a lot of help or very little? Very little. I still will be answering any and all questions that you have. Please, let's take a look at what's coming up. So turn the page past the type 3. Turn the page. So Monday, we will be playing a scavenger hunt game, but it's going to be at your seat. And then turn the page one more. What does that look like? Brand new stuff, right? So as of Tuesday, we are done. We are 100% done with our exponent review, which really makes today that much more important for us to really be working hard and asking questions. So if your homework is squared away from yesterday and you don't have questions, you can get right to your type 3. What I would like you to do right now is compare your homework answers with a neighbor. So who's next to you? Homework was page 14. So page 14, compare with a neighbor, and then let me know what questions you have. If yours is blank, take 5 minutes right now and try some so you can ask questions. So if we have work to do, let's pick up our pencils and get started. Yes. 2 different answers on which one? Number 2? Okay, let's take a look at it.
I have a question about number 12. How would I, do that?
Send in the 3 first.
So, can you,
So let me remind you of the conversation we had in this class 2 days ago about responsibility. My responsibility to you is to help you with the math. Your responsibility right now is to follow the directions that you were given, to stay focused and be working. If you need help getting started, by all means, come on up. But we are not 9th graders, so your work should not be reliant on me physically standing over you right now. So by extension, my directions mean you are staying focused, you are doing your job to stay working right now.
Yeah, so I just put 3 times everything?
Well, but the 3 only is going to apply to what's in parentheses. So this one and that one.
So 3 is going to 12 as well?
Yes. Yep. So if you're squared away with yours and you would like to start the type 3, go ahead and do that because that's what's on the agenda today. Finishing the type 3 is homework. In every class, I've had maybe 3 or 4 people be completely done and finish their type 3, which is pretty awesome. But I'm going to go back a page to page 14, which is what the assigned homework was. You've had a couple minutes right now to compare answers with a neighbor. Which would you like to go over? The first one I heard was number 2. So let's talk about number 2. What question do we have? You tell me what I should do. Six to the third. X to the... X to what power? How do we get 12? 4 times 3. Is 6 to the third 18? Is 6 to the third 18? No. What is it? What is 6 to the third? Good, 216. So when our powers are not too big, we can go one more step. So 216 x to the 12. What else do we have a question on from last night's homework? Number 12. Let's chat. What are we thinking for number 12? Distribute what? Good. Where's the 3 going to go? You tell me. Here and to y. Very good. So let's write what this is going to be. Can I take care of something out front first? What is this fraction reduced to? -1/4. Very good. So -1 will stay out front. What else do I now have in the numerator? X to the 36. Good job. All divided by?
4.
Mm-hmm.
X to the
Mm-hmm.
y to 7.
Very good. Are we done? What needs to move?
X to the -5 and -1.
This piece here. Okay, good question. So x to the -5, I definitely agree with. -1, is that an exponent? No, it's a coefficient. It's going to stay out front. So -1 doesn't go anywhere. So when we bring x to the -5 up, this is going to be -1, x to the 36, y to the third. What else is coming up?
X to the 6.
What's left in the denominator?
4y to 7.
All right. Now what? What's next? Good. We're going to simplify across. What's that going to look like? -1 still up there. X to the 41. Where is she getting 41 from? Good. Can we address the y's at the same time?
Yep.
What's going to happen with these y's? It's going to be y to the 4th. Where?
The bottom.
Good job. In the denominator, because 3 of these y's cancel with how many of the 7? 3 of them, leaving how many behind? 4. So we have -1 x to the 41st power divided by 4 y to the 4th, or to the power of 4. Nice job using correct vocab. Based on conversations with the previous class, I would also like to chat about, on the practice, number 11 on the practice. So this is number 11 on page 12. Because once we're comfortable with our process, right, what do we always do first? What's our standard first step? Before that. If there's an exponent to distribute, send it in, then move negative exponents, then simplify across, then simplify it down. But once you get comfortable with that process, there are cases, remember, there are multiple ways to solve the same problem. So for example, on number 11 right here, is there something I could do before I send in the 3? Yeah. One person sees it. Let me ask the question again. Is there something I could have done on the inside first? What could I have done? I could do 2 times 2 is 4. What else could I have done? N's? What's n times n? N squared, good. What? And m to the fourth is stays. This is still raised to the third power, but now check it out. Instead of having to send 3 to how many terms? 1, 2, 3, 4, 5 places. Now how many times do I need to send it in? Only 3. So let's do it. What is this going to equal? Very nice. Is that 12?
No.
Why is it not 12?
4 times 4 times.
Good job. 4 times 4 times 4 is? Good. This question took us less than 30 seconds. So if we're doing our job of really making sure we're practicing every day, I hope we feel like we're picking up some speed on these. Because the rules and the properties don't change. But hopefully your comfort with using them hopefully will improve over time. Let's take a look at 2 more. Let's chat about how did 21 and 24 go from yesterday's practice? Those are the other 2 that have come up as good conversation questions. How did we do on 21? Look at your 21 and 24 from page 13. How did those go? Who wants to do them right now? I'll take it. Let's do 21. What are we thinking? Great question. He said, are we going to start switching things around or are we going to distribute first? What do you think? We have to distribute first. But at the same time, think about what we just talked about. It's technically not one of our official, 4 steps, but what could I do to make my life way easier? Yeah, can we do some housekeeping up here in the numerator? Make life a little easier? What can we do in the numerator? 2 times 2 is 4. What else could we do? Take care of those y's. What do the y's become? Y to the 4th. Why are they saying 4? Take a look at the screen if you weren't sure. They're saying there's 3 right here, and 1 more right there makes how many? 4. Okay, anything else? X to the power of 6. Again, what page are we on, just to make sure we're all on clear? This is page 13. All divided by, now let's send in that -3. What is that going to be? 2 to the -3. Remember, it's not battleship, not y12. How will we say it? Y to the 12th. Very good. Or y to the 12th power, even better. This 3? See this exponent on the outside? It had to get sent to this 2 and to y to the -4. Because again, if I were to read this out loud, you all the time, you say 2y to the -4 power. But really, what does that mean? 2, what operation is there? Is it 2 plus y, 2 minus, 2 times y, which makes those 2 separate pieces. Take a look how in just one step, does this look much nicer? So if we're good with our properties, like that toolbox of properties, life is nice. What happens next? I'm hearing this word move. Move what? Move the negative, what do you call this? Negative exponents. So tell me what moves. Good job for including the 2. I'm noticing some people are just circling the -3. Is that right or is that wrong? It's wrong. That -3 is an exponent with base of 2, so it all has to move. So on your own, write the next step. What's next?
Can you subtract the y?
I can subtract the y's. What else could I do? What is 2 to the third? 2 to the third, 16? 2 to the third, 8? Let's think about it. How many 2's is it? It's 3 2's. So 2 times 2? Times one more. 8. 2 to the fourth would be 16. So 2 to the third is 8 times 4, 32. So we just took care of 8 times 4. He mentioned the y's. What's going to happen with these y's? Who wants to talk to me about that? These 4 are gone. And is that it? Am I just going to cross that out and call it a day? What? I cross off the 12 and write 8. Very good. Because literally, this means y times y times y 4 times, right? How many y's are in the denominator? 12. So if you actually look at the whiteboard, there's a visual of what 4 y's divided by 12 y's looks like. Do you want to write that out every time? No. Nobody has time for that. But when 4 in the top cancel with 4 in the bottom, notice how many are left in the denominator. How many y's are left? Check out the picture. See there? Right where the, see? 8. 8 are left. So what's left in the numerator? $32. Are any y's left up top? No. X to the 6. Good job. And we're done. Nothing else we can do. That's it. Why can't I do anything with this X and this Y? Two different variables, also known as what? Starts with a B. Bases. Yes. I see some of us, quite a few of us, skipped 24. So let's talk about 24. And good job. Some of us, our practice is complete. So you're starting the type 3, which is great. Use your time well. Those of us who needed some help on 24, let's chat. Talk to me. What am I going to do first? Nice job. So yes, technically we've always been sending in the exponent on the outside. But if there's some housekeeping I can do to make life nice, let's do it. So I heard 2 times 2 is 4. Anything else you can do up top? Those x's. This is technically x to what power? 1. It does become 0. What does x to the 0 equal? Anything to the 0 power equals 1. So what can I do with these x terms? Cross them out. So this whole numerator comes down to 4 times y to the negative 2. Very good. Divided by anything you can simplify in the bottom, in the denominator? No. Now let me stress. If you chose not to do what we just did and you immediately sent 2 in, as long as you did that carefully and didn't make mistakes, you will still get to the same answer. There are multiple ways to get to the same place. With that in mind, you could choose to send the 2 in right now, or do you see something else you could do on the inside? We could divide 4 by 2 and get what? 2. Because 4 divided by 2 is 2. You see anything else we could do? Move what? That's going to move. So what's left in the numerator? Just 2. And what do I have in the denominator? What's still on the outside? Now what do we have to do? There's really nothing else we can do other than what? let's send in that power. So tell me what to write. 2 to the second power. I love how you said that. Good job. 2 to the second power divided by x to the 6th, y to the 4th. Anything else I can do? Yeah, let's use 2 times 2 is 4 instead. Can you combine x to the 6th and y to the 4th? No, because they do not have the same base. So we are done. With our properties, you can literally approach every single problem on this page, on the type 3. It just comes down to doing it. Whose job is that? Mine or yours? Yours. So you have the rest of class today to work with a partner. If you notice that they also haven't done a certain set of questions, work with them. If you want to work by yourself, that's fine too. Let me ask a question. Should I need to stand right next to you for you to be working hard? No. We are less than a quarter away from what grade? 11th grade. Okay? Practically juniors. So as of right now, I'm releasing you to work, which means you are going to stay working really hard from now right till the bell. As questions arise, I will put them up on the smartboard. So ask questions because maybe someone else needs help on that same one. That being said, before you start working independently, are there any others that you weren't sure how to approach? We're good? Okay, great. Choose to work by yourself or with a partner. I'm going to come around. Go ahead. Questions, let me know.
How'd you get 32?
You know how I got 32? How'd you get 32?
What is 2 to the 3rd? And what's 8 times 4?
So you still added to
Multiplying. Multiplying. 8 times 4 gets us to 32.
Alright, so it doesn't have to have a y to multiply?
No, because check it out. Can I buy your pencil? See how you write 4y to the 4th? What operation is technically between the 4 and the y to the 4th? Multiplication, right? And here and here. So even though we don't write those little dots in, they technically are there, correct? And if I were to ask you something more general, like what's 2 times 3? And what's 3 times 2? 6. Did the order matter? No. So the fact that this 4 is right here and this 8 is all the way at the end, can I still do 4 times 8? Yeah, and get that 32. Great question.
Do we add the little numbers on top?
All right, Julio, slide over. I want you both to work together on this set of questions.
Oh, that's what I had to finish the other page.
Yeah, but see how he also needs to work on this as well? So work together.
All right.
You can save this for later because you'll be able to check your own work. So work together on this page. Check next door. Check the Career Center. She may be at lunch. You're working together? Awesome. Good work. Yes. Ooh, great question. Okay. Let's chat. Look at the type 3. It is so tempting. I've seen it all day. For some reason, when we have a number as a base, we feel like rules change. So let's chat about when we have a number for a base. Do you guys want to talk about number 1, number 2, or number 3? 10, 10? What's 10, 10 mean? So let me ask you this. If I had said, this is x, this is 5 to the 4th, right? And this is 5 to the 6th. If I had said x to the 4th and x to the 6th, what would the answer be? Did you do anything to x? No, the base did not change. So if you apply that to here, what's the answer over here? 5 to the 10th. We do not touch the base. If they're different bases, you definitely can't. So what's my answer for number 2? 9 to the, subtract the powers. It is not 1. So for number 3, don't touch the base. 3 to the what? What'd you get up top? 3 to the 16? How did he get 16? He added 6 plus 3 plus 7. Good, and got 16. And then 3, 9. Is that? Let's try changing our words. 3 to the power or to the 9th. Is this all done? No. No, what can I do? Leave the base alone. Don't touch the base. What is 16 minus 9? Notice, from the very beginning, what was your base? And in your answer, what's your base? 3. When you have a numerical base, don't touch it. Okay? So that's a good start on 1 through 3. It's not going to help us out to do 3 to the 9th because then I couldn't do 3 to the 16th divided by 3 to the 9th and subtract my powers. Yes, very good. Good. So what's different about number 5? Check this out. She's asking about number 5. She says, well, what about this 4 and this 3? Does 4 have a power? Technically an invisible what? 1. But what is 4 to the first power? It's just 4. And then 3 technically has a power, but what is it? 1. But what's 3 to the first? 3. So I can do 4 times 3. What is 4 times 3? 12. And how many A's? I heard 8 and I heard 9. I agree. Because how many does this count right here? 1. These questions you ask lead to great parts of our class conversation. So as something comes up, please let me know. Great. Who needs help? Coming over. What's up? Yes, quickly.
Wouldn't it be like subtracting since it's a negative? So
Good.
2 to the 3rd, x to the 4th.
So remember though, power over power. What do you do with the powers?
Oh, you times them, right?
What's another word for time?
Multiply?
Yes, we multiply our powers. How you doing? Yes. Remember, whose job is it to keep yourself focused and working?
I don't know, like, I get it, and then, like, I get when it's, like, all together, and then...
So let's do one together. You want to look at 23?
Yeah.
So housekeeping. I see bunches of X's and Y's up top. So before we even try to do anything else, let's get that cleaned up. So just paying attention to the numerator, what can we do? Gentlemen. Working. I can see from here you're not working.
Do you multiply them or do you add them?
So we are multiplying, so what do we do with the powers when we're multiplying?
Add them.
Correct.
So these 5?
There's 2 here. Yep, good. 2, 2, and 1 makes 5, yep.
That?
Where did y to the 5th come from? Oh, careful. We can't mix up right. So right now, we're just looking at the numerator.
Oh, okay.
So I agree with, I'm not sure where that 2 came from. I agree that up top we have x to the 5th. Y to the 7th? What's 4 minus 2?
I'm looking at it.
Exactly. So don't. If you see how I'm literally covering up the denominator with my thumb so you can't see it? If that helps you, literally cover it up so you just look at the numerator.
Okay,
So let's erase that and also move up so you have some space.
negative 8.
So no work, no credit.
What you mean?
I should see if
That
you.
has to be amended?
I never said that. No, I said in terms of subtraction, like if 3 Y's cross out with 3 of 7 Y's in the bottom, you can cross that out and just write a number. But if, for example, I should see the effect of you sending in the 3. If there are negative exponents that need to move, I need to see those circles. So I need you to go back. Like right here, this just looks like a page of answers for some of these. This one you're not done with. This one I should see you actually sending 3 to every term. There should be at least 3 steps here, not 1. And this is not done because you have negative exponents. So I need you to slow down. It may at one glance look complete because you have work for every question, but be honest with yourself, how accurate is this work? Right? So go back, question by question. Did I show my work? Am I accurate? Am I done?
This is the negative one. This one.
Let me see. I agreed with the 5 X's because we have 2 here, and 1 right there. So that is X to the 5th.
See, that's the confusing thing.
What's confusing?
What you're saying.
Why?
I thought you just do like step by step. And you guys are just.
Yeah, so how many X's is right there? What does X squared mean?
2 X's.
And 1 more.
3.
And then 2 more.
5.
5. Don't overthink it. What's up?
So do I did
Which one?
where is it? Oh, this one right? Number 7.
Really nice. Very good.
Do you think there's got line drop?
I have no idea. Do you want me to write you a pass?
Yeah.
Grab me a little piece of paper, and then you can go check in with her.
Is this Y?
Where would Y to the 6 come from? I would agree if that was a positive 2. So try again. Let me use your pen. DeAndre, do you have the time? The time? Got it. Never mind. You're good. Thank you. Try to be quick so you can get back to work, okay? Very good. Where did that X come from? Yes. Question?
Like, you know how we got a
Yes. Distribute in the power.
still?
Say it again?
If it's a negative?
Still, doesn't matter, negative or positive. Folks, if a power is negative on the outside, you still distribute it in just like you would any other number.
Now, this one is 4 Y's, right?
Mm-hmm.
Is this part of this?
Yes. So what's 4 minus 2? So just Y squared. Why do we have Y squared, Y squared? We just have it once. I think you're overthinking it. Slow down just a little bit. Divide by. Now, inside these parentheses, there's really nothing I can do, so let's send in 3. What is that going to look like?
One.
2 to the 3rd.
Oh, I forgot that. I forgot they're like.
Like, the answer is almost the same as 18. So, kind of count.
Good job. Very nice. Yes. Remember, we're multiplying. So what is negative 2 times 3? What's up? Very quick. Manuel, put the calculator back. He can't use that one, and he knows why. Quickly. Let's mind our own business, though, and stay focused on us. Good job. Now what? Keep going. I think, there you go. Let's move it. Very nice. Good job. Move it. Bring it up. So don't jump the step. Leave what's up top. Bring it up.
Is it bad if I just say like that?
That's fine.
Okay.
So you have x to the fifth y squared, and then what comes up top? What's your question?
For this one,
Yes.
so
Negative 2 hold on, Mrs. Either 9, 6 squared, d, 8. Okay, good. I completely agree with everything you have so far. What's your question?
so when I do this,
Ask yourself, what is negative 2 to the third?
is it -8?
Yes.
Okay. And
And then what's 6 squared?
36?
So those numbers out front I can multiply together. I can do negative 8 times 36, and that'll be out front.
Okay, but does it matter if I do these first and then?
Doesn't matter.
That's not right.
Hmm?
I don't know about it. Started that right.
This one?
Yeah.
What's 4 times? I think, I'm not sure what happened. How did we get 2 to the third?
So I was looking at the other problem.
Well, but we have to multiply, right? So what's 4 times negative 1?
I thought that's still 4, right?
Is it? What's 4 times
Still
negative?
4? Oh, 3. 3.
So I have 3 answers from you right now. You said 4 times negative 1 is 4, and then you said it was 3, and then you said it was negative 4. You're asking me? Pause your thinking and really think about it, and then give me a confident answer. What is 4 times negative 1?
Negative 4?
Yes. So your first step, I should see 2 to the negative 4, and then what's 5 times negative 1?
Negative 5.
So your first step should be 2 to the negative 4, x to the negative 5, and then see what moves.
For this one, would I subtract or just add?
What do you think?
I was thinking subtract because it's in the bottom.
I agree.
Thank you.
Hey,
I don't know if you do what these numbers here.
good question. What is negative 2 to the third? Negative 8. Because see how we have that negative out front? So it's more like saying what's 2 to the third, and then I apply the negative. Because it's like a negative 1. It's like negative 1 times, 1 second. Folks, so I have someone asking me a question, and I'm almost having to talk as loud as if I was teaching the entire class, instead of a level of voice that is talking to someone standing a foot from me. So I'm hearing great math conversations, which is awesome, but someone educate me as to what an inside voice is, or a 1-foot voice. See, I heard her from all the way over there, and she barely talked out loud. So bring the volume down. The person you're talking to is literally sitting right next to you. Thank you. Okay, so coming back to this. This really means negative 1 times 2 to the third. So what is 2 to the third? 8 times negative 1. Negative 8. And then here, what's 6 squared? Right. So then I can do 36 times negative 8, and that becomes my number out front. And then I get my d's together and the e's together, and I'm done. Good question. You see? Once this moves up top, what happens to that? When x to the negative 6 moves to the numerator, what happens to the power? Yes. Hi. Oh, sorry. Here you go. Yes.
Alright, so can you check this one first?
Good.
Okay, and for this one, I can't
You're not working. Sorry, 1 second. Have you ever heard the saying, perception is reality? What does that mean? What's a perception? Right. So how the real world, perception is reality. What it looks like is the first judgment anybody is going to make about what they see, even if it's not exactly true. So I hear your words that you tell me you're working, but when I look over, tell me what it looks like. that is causing me to address you all the time. Perception is reality. So if you're working hard, help me to actually see that, so that when I look up, you actually look like you are working hard. What does working hard look like? Working. Is it laughing for no reason or goofing off? Those do not go together, correct? So when I look up, I want to see you both sitting up, focused on the math. Perception is reality. Thank you. Question. Mhm.
I can't.
Yes, you can.
I can like look like all of them.
You can do 11 times 2 times 9. Mhm.
Well, why? If they got like you know how you talk about the same base.
Because let me see. Technically, they're not the same base, but we know their value. Like this is technically 11 to the first power, which is 11. This is 2 to the first power, which is 2. This is 9 to the first power, which is 9. So then I could. But if this is like 11 squared, well, that's really 121. That's really 121, right? If that was 11 squared. So here, if it's just 11 to that, I can do.
Okay.
So you said leave this 9, but
Mhm.
what do I do for this one?
Here, we're talking 27 ninths, or 27 divided by 9. Can you simplify? Yes. Good.
3 M's?
Yeah, and then work on the ends. Yep. How you doing?
And then to simplify it.
All right, folks. Good job. Pause. Pause. What is tonight's homework? What is on Monday? Did anybody notice? 10-question quiz. 2 questions per assignment we've had this week. So study. Are there any blanks? No. No blanks 9 through 16. Any questions? Send me a remind. Good job, guys. Nice job. See, you can do it. You just have to be patient with yourself. Have a great day, guys.